Welcome to this deep dive. Today we're digging into something called the law of large numbers.
hmm
It's basically about how uh, big patterns can show up even when individual things seem totally random.
Yeah, when you zoom out, basically.
Exactly. We've looked at some material explaining it, and our mission today is really to nail down what the LLN actually is, how it's different from maybe related ideas, and, why you should care.
Sounds good. It's a fundamental concept.
So let's jump in. What is the law of large numbers in simple terms?
Okay, simply put, it means if you do something over and over again independently, that's important. The average result you get, it's going to get really, really close to the true underlying average.
So repeating something, like flipping a coin 1,000 times.
Precisely.
Yeah.
Or, measuring of the height of thousands of people. The more you do it, the closer your sample average gets to the real deal. It's about stability emerging from lots of data.
Now, I saw mention of a weak law and a strong law. Are those, very different?
They're related, but different flavors of certainty. Think of maybe throwing darts.
Okay. The weak law says, look, if you throw enough darts, it's highly probable that the average position of your darts will be near the bullseye.
Probable. Okay.
The strong law is, well, stronger. It says if you keep throwing darts forever, it's almost certain, basically guaranteed that the average position of your darts will land exactly on the bullseye.
So one's about high probability, the other is almost sure convergence. Got it.
Exactly. It's a subtle but important mathematical distinction about the type of convergence.
And this relates to consistency, right? That the sample average is a consistent estimator.
Yes, precisely. Consistency just means that as your sample size grows, your estimate, in this case, the sample average, reliably gets closer and closer to the true population value you're trying to estimate.
Which is why we trust big surveys more than small ones.
That's the LLN providing the guarantee. More data means a more trustworthy average, generally speaking.
And that explains why averages seem to, stabilize.
Yeah.
With lots of data, individual weird results don't matter as much. Exactly right. If you only survey 10 people, one really unusual answer can skew the average a lot.
Yeah.
But if you survey 10,000, that one outlier gets drowned out, the average becomes much more stable and less affected by random fluctuations.
Okay. Now, are there situations where this law doesn't hold? I think independence was mentioned.
Yes, that's crucial. The standard law of large numbers typically needs the observations to be independent.
Meaning one outcome doesn't affect the next.
Correct, like each coin flip is fresh. But if your data points are linked, think daily stock prices, where yesterday influences today, then the basic LLN might not apply directly. Dependence changes things.
So just having a lot of data isn't always enough.
Right. The structure of the data matters.
We can apparently show this with simulations too. We don't have one here, but what's the idea?
Oh, yeah. Simulations are great for this. You'd basically tell a computer to, say, flip a virtual coin thousands of times and calculate the average heads. Then do that whole experiment again, maybe with even more flips. You'd see the average hovering closer and closer to 0.5 as the number of flips increases. It makes the concept visual.
Makes sense. Can you give us a solid, real-world example where the LLN is really key?
Insurance is the classic one.
Right.
An insurance company covers, say, millions of homes. They have no idea if your specific house will have a fire next year. Impossible to predict.
Right.
But across millions of homes, the law of large numbers lets them predict the total number of fire claims they'll likely get with pretty remarkable accuracy. That's how they figure out premiums.
They rely on the average playing out over their huge customer base.
Exactly. The risk is spread out.
Okay, let's tackle a big misconception.
Mhm.
The idea that things even out in the short term.
Yeah.
Like, if a coin lands heads 5 times, isn't tails due?
The gambler's fallacy. No, that's absolutely not what the LLN implies.
Okay, good to clarify.
Each coin flip is independent. The coin has no memory. The chance of tails is still 50-50 on the next flip, regardless of the previous 5 heads.
So the LLN doesn't fix short-term streaks.
Not at all. It only talks about the average behavior over a very long run, thousands, millions of trials. Short-term imbalances are perfectly normal and expected.
What about other stats, like variance or standard deviation? Does the LLN say anything there?
Yeah, it's related. With a large enough independent sample, the sample variance and standard deviation also become more reliable estimates of the true population variance and standard deviation. The principle of large numbers helps stabilize those estimates too.
Okay. And how does all this connect to defining probability itself, the whole frequency idea?
The LLN is basically the mathematical backbone for the frequentist interpretation of probability.
How so?
Well, that interpretation says the probability of an event is the limit of its relative frequency in a large number of trials. The LLN is what guarantees that this frequency will converge to the true probability as the number of trials goes to infinity.
So observing frequency over many trials works because of the LLN.
You got it. It connects the abstract idea of probability to something we can actually observe and measure.
All right, so wrapping this up, the core message is the law of large numbers reveals underlying truths in the long run from seemingly random events, thanks to the power of aggregation.
Yeah, it shows how predictability emerges from unpredictability given enough scale.
But crucially, don't expect it to balance things out tomorrow or next week. It's a long game.
Precisely. Long-term averages, not short-term corrections.
This was really clarifying. So for you listening, here's something to chew on. How does knowing about the law of large numbers change how you look at things? Maybe investment returns, news polls, even just everyday coincidences. Where could this concept help you make more informed judgments? Think about it. Thanks for joining our deep dive.